Hello and welcome. Today we are going to learn how to build circuits in the real world. If you remember, a circuit it's the path to allow the electrons to move from the positive source to the negative source. Yes, of course, you can use the conventional thinking that says it goes from positive to negative. Or you can use the real thinking, that is, the electrons are negative charge, so they move from negative to positive. Don't worry, it doesn't matter. Whatever you want to think, it's okay. The analysis it's exactly the same and there is no problem for this. So, as I said, a circuit it's the path to allow the electrons to move from positive to negative. So I can build a really easy circuit like this. Now this is a circuit, yes indeed, because the electrons moves from positive to negative. That's it. But this circuit it's completely useless because I don't have any reaction, I don't have anything useful for this kind of connection. But something important, even though I don't have anything useful for this kind of connection, I got a problem because as there is no restrictions on this circuit, the electrons are going to move free. And if you remember, I told you that if we don't set restrictions on electrons, they start moving really fast. So this fast movement produces heat. In this kind of batteries, the worst case scenario is that you get this battery to get really hot, and that's it. No problem. No harm on you. But if you got a higher power source, for example, the power source at home, the electrical connections at home, if you do something like this, as you got higher power on your house electrical connections, the heat it's really high and you may burn yourself or you may burn your house. So we need to be really careful. Then again, we always need to restrict the speed and the quantity of electrons moving through a circuit. Otherwise, the elements on the circuit may burn or may get damaged, or worse, you can burn yourself and you can get hurt. So even though this is a circuit, this is not the best way to build a circuit. We need to add something to restrict the speed of the electrons and the quantity of electrons. For that purpose, we got a resistor. This resistor reduces the speed on electrons and also restricts the quantity of electrons. It has a numerical value and you need to use some mathematical formulas to get the proper value for this resistor in order to get the proper characteristics on your circuit. That's out of the scope right now, so we are not going to focus on that. All I need you to understand is that we need the resistor to reduce the quantity of electrons and the speed of these electrons. So now I got a new circuit. Again, the electrons goes from positive to negative and that's okay. And I got this resistance, this resistor who provides some resistance to the circuit, and then the battery is not going to heat up. Okay, I got a new circuit, now I don't have any problem, this is not going to burn, but this circuit it's completely useless. I don't get any useful reaction for this kind of circuit. So even though this is also a circuit, it's a completely useless circuit. I need to provide something extra to get a useful reaction for this kind of circuit. So there are plenty of elements used to get a useful reaction from a circuit. It could be some motors, it could be your computer, it could be your cell phone, or something really easy. This light emission diode. This one produces light when the proper number of electrons pass through this element. So I'm going to build a new circuit. Then again, I'm going to provide electrical connections so the electrons go from positive to negative through an element to reduce to control the electrons, and also through an element to produce an useful reaction. So even though the previous examples were circuits, they were completely useless. So let's say from now on, a circuit for us, it's a path so the electrons can move through some elements to restrict the number of electrons, to control the electrons, and other elements used to produce an useful reaction. So allow me to provide the proper connection. Sorry for this kind of connection, but this is the way I should provide the electrical connections. So now the electrons are going to move from positive like this to the resistance, to the resistor, and this resistor has an electrical resistance that reduces the speed and the quantity of electrons. So we are not going to burn the battery or the light emission diode. So the electrons start moving, comes into the positive connection for this light emission diode, goes through the diode, and then comes out from the negative connection directly to the negative source of the battery. So the path is complete, the circuit is protected, and it's going to produce a useful reaction. There it is. Now I want to show you something. I want to show you what happens if I don't use the resistor. What happens if I don't set a restriction on the number of electrons that pass through the light emission diode. This connection works, but I want to make it easier to see. So this is it, and maybe I can change the color just to understand it. This is going to be black and this is going to be red. Pretty cool. So then again, I got a circuit. The electrons are going to move from positive through the LED to negative and directly to the negative source. That's a circuit. I got an unuseful reaction, but I don't have the element to restrict the number of electrons. What is the reaction I will get? Well, unfortunately, I'm going to damage the LED. The number of electrons through this LED is too high. The LED cannot handle the electrons, and then I'm going to damage the light emission diode. So then again, remember, always use the resistor to control, to restrict the number of electrons moving through any element. So here we go again, the same circuit, and everything is okay. Yay! Now, you may wonder how to build this in the real world. Well, it may be difficult for us to provide these kind of connections in the real world, because the elements we use to create the bridge to the path for the electrons, it's some metallic wire, something like this. Let me show you. So we know from physics that electrons move easier through metallic elements. So we use some metallic wire to allow the electrons to move from the power source to the elements in a circuit. Usually, these kind of wires has some plastic surface around the metallic in order to provide a electrical isolation. That is, in order to prevent non-desired electrical connections, because if this metal part touches this metal part, there is going to be some electrical connection, and maybe we don't want that, right? For example, if you remember here in my virtual circuit, this, you see, this wire, it's touching this wire. In the real world, the plastic surface prevent electrical connections from this black wire to this red wire. That's why the wire has this plastic surface around the metallic element to prevent undesired electrical connections. So how does this wire looks like in the real world? It looks like something like this. You see? It has the plastic surface. You can see this, you can touch it, and maybe if you pay enough attention, you will see, let me try to focus, there it is, you will see the metallical element inside. So we use this to provide electrical connections, but it's going to be difficult, right? This is the light emission diode, and it's going to be really difficult to attach the metallic element to this element. Of course, we can do it. There are some techniques to provide that kind of connections, but usually that kind of connections are permanent connections. They are going to keep attached forever, and as we are learning right now how to build circuits, we may not want to provide eternal connections, permanent connections. No, we don't want that, right? Because, oh, I commit a mistake, I need to remove it and put the proper connection. So if we provide permanent connections, we may be in troubles. So for that, students, we use this kind of element. This element, it's called breadboard, and it's also known as protoboard. There are plenty of options, presentations for breadboard. This is one kind of breadboard. This is another kind, and if you look on the internet, you'll find plenty of options. Most of you should have this one, and maybe few of you may have this one. I show you both of them only to let you know something important. Electrically, both of them are almost the same. Both of them are made of metallic elements inside. But in the other side, back here, you got this plastic surface, and this plastic surface is used to isolate, electrically of course, the metallic elements inside of the breadboard. Let me show you the insides of a breadboard. You will see this if you remove this plastic surface. Please don't remove it. You may damage your breadboard, so don't remove it. This is only for you to learn. So this is how the breadboard looks like in the front, and if you remove the plastic surface, you'll see this inside of your breadboard. Of course, these metallic elements may fall, and then your breadboard is going to be useless. So please don't remove the plastic. As you can see, we got metallic elements inside of the breadboard. These metallic elements are used to provide electrical connections. So if I put something electrical here, some metallic element here, how to do it? Well, I put it inside of these little holes. So I put something in this A hole. That's it. Thanks to the metallic surface inside of the breadboard, any element I put inside of this hole will have electrical connections with D, C, B, and A. So you see, I use these metallical elements to provide electrical connections along these horizontal lines. You may note some vertical lines in the left and the right part of the breadboard. And the reason is that usually we use these vertical lines to provide power to my whole circuit. Remember, positive and negative. So usually we connect the power source here on negative, here in positive, and then I can get positive connections and negative connections in every single hole from this line. As you can see, there is no electrical connection from this vertical line and this second vertical line. So if I want to share power from this positive line to this positive line, I need to provide an electrical connection from positive to positive, and then again from negative to negative. You can see this here. You see my red wire, this is it. This red one provides positive connection from the positive holes from one side to the second side, and the same goes from negative to left, from left, to right. That's it. Now I share power from this side of the breadboard to this side of the breadboard. If you check this kind of breadboard, you may notice these extra connections. And this is because for this kind of breadboards, the metallic surface, the metallic elements inside goes from this part to this part. So from here to here. In the middle, it has some plastic element that gets electrical isolation. So if I want to share electricity from this side to this side, I need to build the bridge to allow the electrons to move from this to this. So that's why I use this kind of connections. I want to show you this because on this kind of breadboards you need to be careful and provide this kind of connections. For this kind of breadboards, don't worry, the whole metallic surface are continuous all along the lines. For this one, they are not continuous, so you need to provide electrical connections. Don't forget that, please. It's quite important. And you can use any of them, doesn't matter. Let's say I want to use this. Yeah, I will use this. So I want to build the circuit I showed you previously. Let me show you the circuit again. It's on second screen. Give me a second. Here it is, and let's go. This circuit. So I need power source, positive, negative, and positive goes to the resistance and the positive connection for my LED, and negative goes to directly the negative part of my LED. So the electrons moves from positive to the resistor to the LED back to negative. Excellent. That's what I want to build in the real world. So first of all, I need to provide power. In your case, when you got your Arduino card, you will see in the lower part a power legend on the board. It says power. So you can get power from these connections. And if you look carefully, you will see several letters on it. Something like reset, 3.3 UV, 5 UV, GND, Bay in, etc. Right now, all you need to know is that positive it's 5V. So I need to provide an electrical connection from 5V to the positive side on my breadboard, the red line. And GND is the negative one. GND stands from ground, 0. It's the reference, the negative, let's say. So then again, I need to provide connections from GND to the negative part on my breadboard, the blue connectors. We can use this wire to get connections from the breadboard or the Arduino to the breadboard. Yes, we can use it, but fortunately you may have this kind of connectors, male to male connectors. You see, it has like a needle, and you can use this needle to provide electrical connections. So I'm going to put the orange one in the 5V connector. This is it, you see, orange 5V, and it goes directly to the red one. So I got positive connection. Cool. I want to do exactly the same. Now for GND, negative. So I put the purple one on GND, and the purple one goes in the blue connectors. You may say, is that really important for me to put the connections on this part? No, remember, we got electrical connections all along this line. So I can put the orange here, and the purple can be here, and I still have electrical connection. So it doesn't matter, okay? The numbers and the position are useful for us to identify the elements, but they are not mandatory. You don't need to put it exactly in the precise hole I do. No, you can put it here or here, and you can put this here, and it doesn't matter. So let me just put it here because I like it that way. You can put it as you wish, it doesn't matter. And now, if you remember, I need to put the light emission diode. So I need to provide negative connection to the negative part of the LED. How do we identify the negative part? Well, usually the LED has this flat shape in one part of the LED and a round shape in the second part of the LED. So if you pay attention carefully to the LED, you may or may not, it may be difficult even in the real world. While you are holding the LED, it may be difficult to identify, but look carefully. I hope you can see this is the flat part and this is the round. It might be difficult. So when the LED is brand new, we can use this trick. As you can see, there is a short leg on it, short, and a long one here. So the short one, it's the negative, and the long one, it's the positive. Teacher, what happens if I cut the legs and now I don't see any long leg and any short one? Don't worry. Inside of the LED, you will see a big triangle, metallic triangle inside, and a short one. So the big one, the flag, some people say this is like a flag. So let's say the flag is the negative and the short is the positive. So back to my circuit. I need to connect the short leg, the negative one, into the negative connection. I can do something like this, and this is going to work. You see, this is the short one, this one it's the short one, and it's on negative, and I got my big leg, the positive one, in this part of the breadboard. Why I need to do that? Why don't I put it like this? positive and negative directly? Well, because remember, we need to add the element to control the electrons. If I turn this on, I'm going to damage this LED. You may not be able to see anything. It is not going to spark or burn itself. Now, it's going just to turn on really fast, less than a second, and then it's going to turn off, and the LED is damaged and it's not going to work anymore. So nothing interesting. So please avoid this. Remember, I need to provide some element to restrict the electrons through this LED. So I need the resistor. And this is it. This is my resistor. I need to reduce the speed and the quantity of electrons moving through this element, otherwise I'm going to damage. So let me remove this, and if you remember the circuit from my simulation, let me make it smaller, the resistance goes from positive to the resistor and to the positive connection of the LED. So let us follow this instruction. I need to connect one of these leg from the resistor to positive. So I need to put this into the red line of my circuit. So I put it like this. That's it. Now I got the positive connection on my resistor. I got this connection. I need to provide this second connection. So it goes from the free leg of the resistor to the positive connection on my LED. So back to my circuit, I identify the long leg. This is it. This is the long one. So I put it like this in this line. Let's say line 44. The positive it's on line 44. This is it. This one, sorry, it's hard to point. This is line 44, and there is the positive, and the negative it's on line 42. Remember, we got electrical connections in this way. So the positive again goes to 44. Like this. That's it. So inside of the breadboard we got the metallic surface. I got something like this. So this metallic surface provides this electrical connection. Cool. Now the only thing I need to do is to connect the negative leg from the LED to the negative part of the power source. Back into my circuit, all I need to do is to get a connection from line 42 to the blue connector. Teacher, do I need to use 42 and 44? Nope. You can move them, you can put them anyway, it doesn't matter. The numbers are only useful for us to identify, but the position is not important. What is important for us is the electrical connection. So if now my positive leg is on line 42, I need to move the resistance to line 42 because I need to provide the previous electrical connection. So the numbers are not important, okay? On my examples I may use some numbers, and you don't need to follow the numbers. You need to follow the electrical connections. Now we still have missing the connection from a negative to the blue line. Let me move this back because I want this to be let's say symmetrical. I like symmetrical circuits, so let me change it again. I move it again, doesn't matter as long as I provide connections. And now I need to connect line 41 to the blue line. Yes, of course, we can use this kind of connectors, male to male, from here to here, and it's going to work. But this is not the proper way for us to do it. We should use this kind of connectors, the wire, to provide connectors in the breadboard. So the jumpers or the male-to-male connectors are used to provide connectors from the board to the breadboard. These kind of connections, this. But to provide connections in the breadboard, we use this, and this is the trick. This is what we need to learn today. How to remove the plastic surface in order to get some metallic element to put it inside of the breadboard and provide the connections. Like this is not going to work. It doesn't even fit. So no, this is not. So we need to remove this plastic surface. And here is the trick. We got plenty of tools. We may have something like this, some trimming tool, and we can use this to remove the plastic surface. You need some practice for this. You need to, this is like some scissors, so you press slightly. If you press too hard, you are going to cut the metallic element like this. You see? It fall apart. And we don't want that. Here it is. I trim it. We don't want this, right? We just want to trim the plastic surface. So you need to press slightly and then you pull the wire. And there it is. You remove the plastic surface and now you got the metallic surface free to put it inside of the breadboard like this. You push, okay, push harder, and there it is. We got the connection. This is the most common way for us to doing this kind of connection. And don't worry, you may have other options. Maybe you got this kind of tools, and you will see that in the middle it has some trimming part. So you can use this part in the same way. If you press too hard, you will trim the metallical element. Now you see, no metallic because it's here. Let me show you. Here it is, really small. This is it. I trim it. So again, I don't want to trim it. I just want to press slightly to cut the plastic, and then I pull like this. And that's it. You need practice for this. It's not easy. You need to try again and again. But as long as you get practice, you will do it. You may say, is there any other option? I don't have these tools. Don't worry. You may have some scissors, so you can try with scissors. You can do it. I don't have scissors. Well, you may have a cutter, so you can use the cutter to remove the plastic surface. It may be harder, but I'm sure you can do it. And you need practice. And also, please be careful. You see, I did it. Be careful, don't cut yourselves. You see? There it is. I did it. So there are plenty of options. Use your imagination. In particular, I'm going to show you a really neat trick. Let me do it. You can use a lighter like this to burn the plastic surface and make it easier for us to remove it. All you need to do is turn the lighter, put the light near the plastic surface, and so as you can see, it burns. Wait for a second because this may be hot, but when this is done, it is really easy for you to remove it just pulling it. You see, it falls. It's really easy. It's a really useful and neat trick, and you can use this trick. For me, the truth is that I got used to this kind of tool, so I'm going to use this. So slightly pull, and there it is. And you can trim the missing parts. That's it. So I put this on the negative part. Let me put it. And so you take the distance, more or less, something like this. Here, this is the distance. So you take this out, you trim the plastic on the distance you said, and you can use this kind of tools or the lighter. Let's use the lighter. Yes, now it's time for the lighter. So again, you turn it on, you burn the plastic, wait for a second because it's hot. If you touch it, you may burn yourself, and you don't want that. So wait, ready, and you remove the plastic. You see, really easy. It's not so clean, yeah, you got dirty, but it works. So now you got the proper shape, and put the connector as you planned at the very beginning. Let me put it like this, and I'm going to move it this way, and I'm going to put this, the second part, like this, and there it is. You see, this black connection provides the connection from negative to the negative part of the LED. Actually, you get the negative to this little hole, but down in this little hole we got the metallical element that produce electrical connection with the negative leg on my LED. So this is going to work. Excellent. Now my circuit is complete. All I need to do is to provide power using the USB connector. So there it is, and my LED turns on. And when I remove the power connection, it turns off. So this is it, students. This is the way for us to build circuits in the real world. We use some wire, metallic wire, and any tool you got in order to trim the metallic element and to remove the plastic surface. Well, I hope you enjoyed this video. I hope this is useful for you, and see you the next time. Bye bye.